In this video, we're gonna solve some numerical problems related to the Millikan's oil drop experiment. Here we have some numerical problems. I think before to enter into the numerical problems, we must know some important formula. Here we have some formula. When the oil drop is falling under the effect of gravity alone, that means in the absence of electric field, with certain terminal velocity v1, in these conditions we can find the radius by using the formula r is equals to under root 9 eta v1 divided by 2 bracket rho minus sigma g. This is the formula to find the radius of the given oil drop. When the oil drop is falling under the effect of gravity but in the presence of electric field E, when the electric field is applied and the given oil drop is charged, at that conditions the terminal velocity will be changed. Let's say v2 be the new terminal velocity with which the given oil drop is still moving in downward directions. So at that conditions we can find the total charge in the given oil drop. Q is equals to 6 pi eta by E under root 9 eta v1 by 2 bracket rho minus sigma g into v1 minus v2. The first one is the terminal velocity in the absence of electric field, whereas the v2 is the terminal velocity after applied the electric field. If the given oil drop is still falling in the downward directions after applied the electric field with new terminal velocity, we have to write here v1 minus v2. But some of the cases, when the electric field is applied in between the parallel plates, the given oil drop start to move in upward directions with certain terminal velocity v2. At that conditions, the negative sign will be changed by positive sign here. By using this formula, we can find the total charge in the given oil drop when it is falling in downward directions or it is moving in upward directions with the new terminal velocity v2 in the presence of electric field. In some of the cases, when the electric field is applied, the given oil drop is found to be suspended in between these two parallel plates. That means the given oil drops becomes motionless. So at that conditions, we have to use the another formula, that is Q is equals to 4 by 3e pi r cube bracket rho minus sigma g. So this is the formula to find the total charge in the given oil drop when the oil drop is found to be suspended in between two parallel plates. That means motionless. Sometimes we have to find the number of electrons in the given oil drop. Then we have to use the concept of quantizations of charge, that is Q is equals to Ne. By knowing the value of total charge in the given oil drop and charge of the electrons is the well-known things, we can find the number of electrons in the given oil drops, which is called quantizations of charge. So these are the some important numericals formula to solve the given problems. Okay, now let's move to the problem. The first problem is here. In a Millikan's oil drop experiments, the terminal velocity of the droplet is observed to be 1.3 millimeter per second. Here is no mentions of electric field. That means the terminal velocity here, that is the first terminal velocity v1 is equals to, here we have given 1.3 millimeter per second. This is not the SI unit, so we have to convert into the SI unit. Then we will get 1.3 into 10 to the power minus 3 meter per second. So this is the terminal velocity in the absence of electric field. The questions, this is the terminal velocity in the absence of electric field. According to questions, if the density of the oil is 900 kg per meter cube. Oil, density of oil is also given here. Density of oil represented by the rho is equals to 900 kg per meter cube. This is the density of oil, and density of air is not mentioned here, so we have to neglect it. That means sigma is equals to 0. Density of air. The another parameter, viscosity. Viscosity is given here. Viscosity eta is equals to 1.82 into 10 to the power minus 5 kg per meter second. This is the coefficient of viscosity of air. Now the first question is here, we have to find the radius. Radius r is equals to what? And second one, mass of the given oil drop m is equals to what? Here the conditions is, in a Millikan's oil drop experiments, the terminal velocity of the oil drop is observed to be this much. If the density of oil is 900 kg per meter cube, and calculate the radius and the mass of the given oil drop. The first question is about the radius, and we have already mentioned the formula to find the radius. So radius r is equals to what we can write, root under 9 eta v1 by 2 bracket rho minus sigma g. Acceleration due to gravity, we can write the value of acceleration due to gravity as the 9.8 meter per second square, and other physical parameters are given in the questions. Let's write some parameters here. 9 into 9 times eta means 1.82 into 10 to the power minus 5 into the terminal velocity 1.3 into 10 to the power minus 3 under root 2 bracket rho means 900, sigma is not mentioned, so we have to neglect as 0, and 9.8. By calculating the numericals value here, we will get 3.47 into 10 to the power minus 6 meter. This is the radius of the given oil drop. The first answer is 3.47 into 10 to the power minus 6 meter. This is the radius of the given oil drop. Now move to the second questions. We have to find the mass of the given oil drop. For the mass m, we can use the formula volume into density, and volume is the volume of the spherical object oil drop means 4/3 pi r cube. This is the volume, and rho is the density of the given oil drop. 4/3 into pi means 22/7 into r, that means radius we already got here. 3.47 into 10 to the power minus 6 to the power cube into 900. By solving all the numericals value here, we will have 1.58 into 10 to the power minus 3 kg. So this is the mass of the given oil drop. So by using these two formula, we can find the radius and mass of the given oil drop. Now let's move to the second questions. Look at here. Our second questions is, in a Millikan's oil drop experiments, a drop is observed to fall with terminal speed of 1.4 millimeter per second in the absence of electric field. The first conditions here, in the absence of electric field, terminal velocity v1 is given, which is 1.4 millimeter per second. When we convert into the SI system, we will get 1.4 into 10 to the power minus 3 meter per second. This is the first terminal velocity in the absence of electric field. When a vertical electric field of this much, vertical electric field, that means E, 4.9 into 10 to the power 5 volt per meter, electric field in between the parallel plates is also given. So in the presence of, after applied the electric field, the droplet is observed to continue to move downward at a lower terminal speed. After applied the electric field, there will be new terminal velocity of the falling oil drop, which was found to be 1.21 millimeter per second, and when we convert into the SI system, 1.21 into 10 to the power minus 3 meter per second. Now we have to calculate the charge on the droplets and how many quantum units of the charge does the droplet possess. That means the first question is the total charge in the given oil drop, and second question, that means the how many quantum units, that means the number of electrons, is equals to what. These two are the questions, problems that we have to find in these questions. And the additional given are here. Density of air, that means sigma is mentioned here, 1.29 kg per meter cube. Density of oil is also given here, rho is equals to 750 kg per meter cube. Viscosity is also given here, 1.8 into 10 to the power minus 5 kg per meter second. These are the givens, and these two are the problems that we have to find in these questions. First, let's find the total charge in the given oil drop. When the charged particle is still moving in downward directions even after applied the electric field, the formula to find the total charge in the given oil drop, Q is equals to 6 pi eta by E under root 9 eta V1 divided by 2 bracket rho minus sigma G bracket V1 minus V2. When the oil drop is still moving in downward directions, then there will be minus in between V1 and V2. By substituting the value of all the given parameters here, 6 pi eta means 1.8 into 10 to the power minus 5 divided by electric field 4.9 into 10 to the power 5 under root, this is the expressions of radius, that 9 into eta means 1.8 into 10 to the power minus 5 into first terminal velocity 1.4 into 10 to the power minus 3, the first terminal velocity. The lower part 2 bracket rho means 750 minus 1.29 into 9.8 as a acceleration due to gravity into the new terminal velocity 1.4 into 10 to the power minus 3 minus 1.21 into 10 to the power minus 3 second terminal velocity. By solving these all the numericals value here, we will get the total charge in the given oil drop is found to be 5.17 into 10 to the power minus 19 coulomb. This is the first answer. The total charge in the given oil drop is found to be 5.17 into 10 to the power minus 19 coulomb. The second question is how many quantum units of charge does the droplet possess? That means the number of electrons in the given oil drop is equals to what? By using the concept of quantizations of charge, Q is equals to NE and N is equals to Q by E. The total charge we already found here, 5.1 into 10 to the power minus 19 divided by charge of the electrons 1.6 into 10 to the power minus 19. 10 to the power minus 19, 10 to the power minus 19, we can cancel each other, and by dividing 5.1 by 1.6, we will get here 3.23 electrons. But we already know that charge is always quantized. That means charge only can exist in the number of electrons, not in the decimal. So the nearest number is 3. So there are 3 electrons in the given oil drop. So 3 is the quantum number here. Quantum number n is equals to 3. By solving these questions, we came to know that there are 3 electrons in the given oil drop. So first one, the total charge in the given oil drop is 5.17 into 10 to the power minus 19 coulomb, and the quantum number is found to be 3. Now let's move to the next questions. Here, a charged oil drop in Millikan's apparatus is observed to fall through a distance of 1 millimeter in 27.4 seconds. Here, the velocity is not mentioned directly. The questions has given here the distance d is equals to 1 millimeter. That means 1 into 10 to the power minus 3 meter has covered in 27.4 seconds. Time is mentioned here, 27.4 seconds. Now we have to calculate the terminal velocity. V1 is equals to d by t. d by t, that means 1 into 10 to the power minus 3 by 27.4. Here, then we will get here 3.65 into 10 to the power minus 5 meter per second. So this is the terminal velocity of the given oil drop. Now, in the absence of electric field, the same drop is held stationary when the field of this much, that means electric field is applied here, 2.37 into 10 to the power how much 4 Newton per coulomb is established between the plates, and when we applied the electric field, the oil drop is found to be stationary. It becomes motionless. In these questions, we have to find the total charge in the given oil drop first, total charge in the given oil drop, and then we can find the excess number of electrons in the given oil drops, so that the oil drops can be suspended in between the given parallel plates, In the motionless conditions, that means in the stationary conditions, when the oil drop is just motionless, there are two forces acting in the upward direction, that is electric force plus upthrust, and the downward force is only weight. So Fe plus upthrust is equals to weight. So Fe is equals to what we can write here, W minus U. That means QE is equals to QE is equals to V rho G minus V sigma G. So V bracket rho minus sigma G. So Q is equals to V means 4 by 3 pi r cube bracket rho minus sigma G. And the electric field we have to taken in the denominator in the other side here. Radius of the given oil drop, we have to also use the formula to find the radius here, 4 by 3e, 4 by 3e. Let's find the radius separately so that we can easily solve these questions. R is equals to root under 9 eta v1 by 2 bracket rho minus sigma g. Here R is equals to under root 9 into the value of eta is given in our questions, that is 1.8 into 10 to the power minus 5 into terminal velocity we have calculated here 3.65 into 10 to the power minus 5 and divide by 2 bracket rho, that means density of the given oil drop 824 minus density of air is also given 1.29 into 9 point no, here acceleration due to gravity is mentioned in the questions, we have to taken as a 10. By solving all the numerical quantities here, we will get the radius of the given oil drop. Here the radius of the given oil drop is found to be just use your calculator to find the radius here. I have found 6.05 into 10 to the power minus 7 meter. The radius of the given oil drop is found to be this much. So using this value in here, 4 by 3 pi r means 6.05 into 10 to the power minus 7 power cube bracket rho means 824 minus 1.29 into 10. Use the calculator to find the numericals value here. We can also we have to use the value of E, 4 pi by 3 into E means 2.37 into 10 to the power 5. No, there is a 4 into 6.0 6.05 into 10 to the power minus 7 whole cube bracket 824 minus 1.29 into 10. By solving all the quantities here I have found 3.21 into 10 to the power minus 19 coulomb. This is the total quantity of charge in the given oil drop. Total quantity of charge. Now the next part is how many excess electrons has the droplet acquired. That means how many extra number of electrons should the given oil drop have. So here Q is equals to N, that means N is equals to Q by E. Q is equals to 3.21 into 10 to the power minus 19 and charge of electron 1.6 into 10 to the power minus 19. We can cancel these two quantities. Now here we got 2.01 something. So the charge is always quantized, so that we have to write there are only 2 electrons in the given oil drop. So excess number of electrons required to be a motionless in between the two parallel plates, there must be 2 electrons. So here N is equals to 2. In this way we can solve this problem. Now let's move to the next questions. Here the question is, in Millikan's oil drop experiments, one looks at a small oil drop held motionless between two plates. This is also the questions related to the motionless conditions. Take the voltage between the plates be 2033 volt. Potential difference is given here. PD, that means V is equals to 2033 volt. This is the potential difference between the two parallel plates. And these plates are separated by a distance D. That means 2 centimeter. Whenever there is a potential difference between the two plates and the separations between the two plates, we can easily find the electric field set up between the parallel plates given by V by D. V means 2033 divided by 2, we have to convert into SI, 2 into 10 to the power minus 2 into 10 to the power minus 2, then by solving this numerical value we will get 1.016 into 10 to the power 5 volt per meter. This is the uniform electric field set up in between the two parallel plates. Now the oil drop, the density of oil drop is given, rho is given here, 0.81 gram per cm cube. This is the CGS unit. We have to convert into the SI unit, so we have to multiply by thousands, then we will get 810 kg per meter cube. SI unit has diameter D is given 4 into 10 to the power minus 6 meter, and if we have to find the radius, that means D by 2 into 10 to the power minus 6 meter. This is the radius of the given oil drop. Now the question is, we have to find the total charge Q is equals to what, and the number of electrons N is equals to what, quantizations of charge as well, right? Okay, whenever there is a two parallel plates and the oil drop is found to be motionless between the two parallel plates, the potential difference is 2033 separated by a 2 centimeter, right? And the shortens parameters of the oil drop is given. It is the stationary conditions, motionless conditions. So in the motionless conditions, the formula to find the total charge Q is equals to 4 by 3e pi r cube rho minus sigma g. Here the questions have given only density of oil, not the density of air, so we can neglect the value of sigma. Total charge Q is equals to now 4 by 3 into E means 1.016 into 10 to the power 5 into pi, R means 2 into 10 to the power 6 to the power cube bracket 810 minus 0 into 9.8. By solving these numerical value, use the calculator to solve the numerical value. Now I get the total charge in the given oil drop is 2.6 into 10 to the power minus 18 coulomb. The total charge in the given oil drops, which is suspended in between the two parallel plates when the potential difference of 2033 volt is applied between the two parallel plates separated by 2 centimeter. So this is the total quantity of charge. Now the second part is to find the number of electrons in the given oil drop by the concept of quantizations. Q is equals to N and N is equals to Q by E. Total charge we already found here, 2.6 into 10 to the power minus 18 divided by 1.6 into 10 to the power minus 19. By the calculations here, I have found 16.37 electrons. So here 16.37 electrons, then the total charge is always integral multiples of the number of electrons. So total charge is equals to 16 electron. So number of electrons is equals to 16. There are 16 electrons in the given oil drop. So in this way we can solve this problem. Now let's move to the next questions. Here we have some parameters are given in the questions. In a Millikan's apparatus, the horizontal plates are 1.5 centimeter apart. That means the separations between the two plates is given, that is d is equals to, so d is equal to given, d is equals to 1.5 centimeter is equals to 1.5 into 10 to the power minus 2 meter. And this is the separation between the two parallel plates. An oil drop is observed to fall with the steady velocity, that means terminal velocity in the conditions, first conditions v1, in the absence of electric field is given 2.5 into 10 to the power how much, minus 2 centimeter per second. That means 2.5 into 10 to the power minus 4 meter per second. Terminal velocity in the absence of electric field, 2.5 into 10 to the power minus 4 meter per second. When the electric field is applied, the upper plate being positive, the drop just remains stationary. Here is also the same conditions. When the electric field, uniform electric field is applied here, electric field is applied in the downward directions, being the upper plate as the positive plate, the oil drop is also found to be motionless. The oil drop is found to be motionless between the two parallel plates. That means the total upward force acting on the given oil drop due to electric force and the upthrust is sufficient to balance its weight, so that the oil drop is found to be motionless between the parallel plates. For these conditions, uh, the potential difference between the two plates is given as 1500 volt. Distance between the parallel plates is given, so that the electric field E is equals to V by D. B means 1500, D means 1.5 into 10 to the power minus 2. So here we can 10 to the power around 5, right? 10 to the power 5 volt per meter. This is the uniform electric field setup between the two parallel plates. Calculate the radius of the drop. The questions is about to find the radius of the oil drop. First questions, and the number of electrons, also the number of electrons, quantizations. Okay, we have the formula to find the radius. R is equals to root under 9 eta v1 divided by 2 bracket rho minus sigma g. This is the basic formula we have often used, so that it becomes used to. So R is equals to root under 9 into, eta is also given here, 1.8 into 10 to the power minus 5 into v1 means terminal velocity 2.5 into 10 to the power how much, minus 4 meter per second, divided by 2 bracket rho means 900, here is given 900, and density of air is not mentioned, so we can write 0, we can neglect it, into 9.8. By the calculations of these numericals value, the radius of the given oil drop is found to be 1.5 into 10 to the power minus 6 meter. Use your calculator to solve the numericals quantity here. I have found the radius of the given oil drop is 1.52 into 10 to the power minus 6 meter. This is the first questions. We have to find the radius, and the second part is to find the number of electrons. For the number of electrons here, for the number of electronic charge, neglecting the air density, for the number of electronic charge, the total charge, we have to find the total charge Q is equals to 4 by 3e pi r cube rho minus sigma g. This is the formula to find the total charge. Let's use the value of all the parameters given. 4 by 3 into e means 10 to the power 5 pi r, we have already found here 1.52 into 10 to the power minus 6 को power cube into 900 minus 0 into 9.8. By solving all the numericals value here, the total charge in the given oil drop is found to be, in these questions, use your calculator. I am using the calculator here. So 1.29 into 10 to the power into 10 to the power 18 minus 18 coulomb. I have found the total charge in the given oil drop is 1.29 into 10 to the power minus 18 coulomb. This is the total charge in the given oil drop. Now, for the number of electrons, Q is equals to NE. So, N is equals to Q by E. So, Q 1.29 into 10 to the power minus 18 divided by 1.6 into 10 to the power minus 19. Solving these quantity, here I have found 8.1 electrons. So, there are 8 electrons in the given oil drop, and by applying the electric field, the oil drop is found to be suspended in between the two parallel plates. These are some numerical problems related to the Millikan's oil drop experiment.